In a previous video, I talked about the 3 laws of thermodynamics. In this video, I want to focus on the second law of thermodynamics, which deals with this idea of a spontaneous process. And it says, for a spontaneous process, the change in entropy overall, so in our universe, must increase. And then we said that there was kind of 2 pieces of the universe entropy. Right? We could say the entropy of the universe is equal to the entropy change of our system and the entropy change of the surroundings. Okay. Now, if we're looking at what does this mean for us with regards to the entropy for our system, we can actually calculate that fairly easy looking at maybe some standard entropies that are provided to us or calculate it any other number of ways. Okay. We don't want to look at this overall universe change through 2 lenses. We don't want to look at it through the lens of the system and then try and look at it through the lens of the surroundings. We want to try and look at it through the lens of just one of these. Well, we already have a good viewpoint from our system. Most of the things we talk about, like our enthalpy change, our change in entropy, that's through the lens of the system. So we want to try and get this into some form that deals with the lens of our system. Okay? So what we'll see is that the change in entropy of our system, our surroundings, this piece right here, is actually equal to the amount of heat that our surroundings gains at a specific temperature. Okay, and we're typically dealing with absolute temperatures here, so I'm going to put sub K there to show that it's at a Kelvin temperature. So again, this doesn't do us any good yet because it's still dealing with the heat of the surroundings. Well, we also remember, right, however much heat that the surroundings gains, that's equal and opposite to the heat that our system loses, okay, or vice versa. So now again, we can rewrite this to be, we'll go ahead and plug this in right here. And so we see, well, now that's equal to the Q of our system divided by our temperature, okay, in Kelvin. Now if we go back to looking at, well, now we know the Q of our system. Well, if we deal with this at a constant pressure situation, what does that mean for us? Well, that means the Q of our system is equal to the enthalpy change of our system. Okay? And so now we've gone from the total entropy change of the surroundings to something that describes just our system. So now we can say the change in entropy of our surroundings is equal to, go ahead and put this last piece in here, right? The negative of the change in enthalpy, excuse me, of our system divided by the temperature that it's sitting at in Kelvin. Okay, so now we can go ahead and rewrite this to be, well, now this is equal to the entropy change of our system. Okay, now we can replace the change in entropy of our surroundings to be minus the enthalpy change of our system at a specific temperature in Kelvin. Okay, so now what does that mean for us as we're trying to identify things that contribute to spontaneity? Okay, well, we want this to be overall to be greater than 0. Well, that would mean that we would want our change in entropy to be positive, right? That's something that would contribute positively to our reaction being spontaneous. Well, the other piece would be our enthalpy. Well, again, we want this whole value right here to be a positive value. We want to add to that. Well, the only way that happens is if our enthalpy is negative, right? We have an exothermic reaction, because then that would make this overall piece positive. And so now we see that there's 2 things that contribute to a reaction being spontaneous, okay? Where we have a delta S that is positive, right? Or we have an exothermic reaction, right, which would be a negative enthalpy change. So we see those 2 pieces contribute to a spontaneous process. And now we've gone from the lens of the universe to 2 different lenses of system and surroundings to just looking now at our system and the entropy change and the enthalpy change of the system. And that tells us something about whether our reaction or process is going to be spontaneous or not. And we can actually calculate this based upon known values of our entropy and known values of our enthalpy. So in the next video, what we're going to do, we're going to unpack this a little bit more, and we're going to see how do these things relate to the Gibbs free energy change for a reaction.